Welcome to this video. My name is Mark Scythian. The date today is July 3rd, 2024. So in this video we're going to cover the circle, tangent, triangle, area problem. You probably run into this in your geometry or trigonometry homework where either the square root of 2 or the 3, 4, 5 rule can be applied to quickly solve the problem, but it is always good to use the proof or analysis method, reinforcing the fundamentals in trigonometry and geometry. So just to be absolutely certain for your calculation. So that being said, we can look at the given tangent with respect to the circle. This is the bisected symmetry point of the triangle. And so the radius that it's taken from for its bisection point is 1 inch. We'll call it 1 inch. There's no units here. And we have to find the area of triangle ABC. So if we were to swing this radius the opposite direction, we would then be able to calculate the midpoint to C length as 1 inch as well. So we have an isosceles triangle established from that bisection or midpoint symmetry, which then posits also the midpoint to A as 1 inch in length. So the actual segment length of line AC is equal to 2 inches. And then all triangles have 180 degrees. The problem specifies that we have a 90-degree right triangle, so that's 90 degrees. And because we have symmetry, the remaining 90 degrees of 180-degree triangle are then split in half, so that means the angle of both sides, both angles A and C, are 45 degrees. So now we can apply the rules of trig with respect to cosine, sine, or tangent. But first we have to establish the correct side. So from, let's say, the angle of C, this angle, we project an opposite leg. And then that leaves us with the adjacent leg. And then, of course, the hypotenuse. So let's say we're going to work with the adjacent side with respect to the hypotenuse. So if we're dealing with adjacent over hypotenuse, that is a function of cosine. So we can take the cosine of 45 degrees held in your calculator's degrees mode, then made equal to the adjacent side length, which we don't know, we'll call it A, divided into the hypotenuse length, which we do know, 2 inches. So if we find the cosine of 45 degrees in your calculator's degree mode, 0.7071. So make sure your calculator is not in radian mode, but it is in degree mode. Then cosine of 45 degrees will equal 0.7071. This then made equal to the adjacent side divided into 2 inches. So we can just multiply our output value 0.7 0.071 times 2 inches, the denominator, to get the numerator, the adjacent side. So 0.7071 times 2 inches will equal 1.41. And again, it's the 3-4-5 rule, or the square root of 2 bisected symmetry of a triangle. But we've proved this through an analysis method, so we know that the length of side B to C is equal to 1.41 inches. So all that's left, if we're going to use an analysis method, obviously we have 2 square roots of 2. We could then just apply the Pythagorean theorem. So the adjacent and opposite legs would either be A or B or B or A. So we'll just assign the opposite side as the side A and the adjacent side as the side B, and then the hypotenuse is always and only C. So if we apply the Pythagorean theorem, we have A squared plus B squared is equal to C squared. So A squared, because we don't know the side of A or its value, plus B squared. B is line C, or line B to C, so that's 1.41. Squared, then made equal to side C, which is 2 inches squared. So this becomes A squared plus the square of 1.41. This is 1.9881. Then made equal to 4. 2 squared is 4. So this means A squared is equal to 4 minus 1.9881. So that means A squared is equal to 2.0119. So we can solve for A, which is equal to the square root of 2.0119. And so A is equal to 1.41. So side AB, 1.41. Side segment line BC, also 1.41 inches, or the square root of 2. And then the hypotenuse side line AC is 2 inches. So now if we just get rid of all this and keep the side values, we can then just use the application of base times height divided by 2, or the area of a triangle. So we have a base of 1.41 times a height of 1.41, so essentially a square bisected on its hypotenuse into the triangle. So we divide that by 2. And then we get 0.994405 square inches, which is approximately 1.0 square inches triangle. So of course, many use the axioms to just solve this problem in 5 or 10 seconds, but just in case it slips from your studies, this lecture focuses more on the analysis method, so that if you don't know, you can analyze and reach the absolute certainty and know that the answer is 1 square inch. Thank you for watching this video and have a great day.